Alright, let's look at a few of these questions here. The first one, we want to use intercepts to graph the equation negative x plus 2y equals 3. So, first thing I'm going to do is write that down. If I can find my pen, there it is. Negative, and I forgot the equation, of course. Negative x plus 2y equals 3. Okay, so I want to use the intercepts. There are two intercepts, X-Intercept and Y-Intercept. If I find the X-Intercept first, I want X in an X-Intercept, which means that Y has to be 0. So we go ahead and plug 0 in for Y. So negative X plus 2 times 0 is 0, equals 3. So if I divide by negative 1, X equals 3. Okay, so that intercept, remember that y was 0, I just found that x is 3, so that intercept is the ordered pair 3, 0. Okay, that's my x-intercept. Let's find the y-intercept. So for the y-intercept, I need y, right? So I know that x has to be 0. So I've got 0 plus 2y equals 3. So if we divide by 2, we see that y is 3 halves, or 1.5. Okay, so that's our y value. We know our x value is 0, so put those together, it's 0, 3 halves, or 0, 1.5. So these are my two intercepts. I'm going to go ahead and graph those. Alright, so click on my graph, make it bigger here. The first one was negative 3, 0, so negative 3, 0. And the second one was going to be positive 3 halves, so positive 1.5. Oops, right there. Okay, so let's save that one and go to the next one. Okay. Now, by the way, this did specifically ask us to use the intercept, so no other ordered pairs would do for this one. It did have to be the two that were right on the line. There are tons of other ordered pairs. Like, for example, if I would plug in 3 for x, I would get 3 for y, and that would be another ordered pair that's true, as I can see right here. But it would not be an acceptable answer to a question that asked me specifically to use the intercepts. Okay. I should be able to... I'm in review mode, so I was going to say I should be able to check my answer, but I'm in review mode, so I can't. That's why. Okay. So number 22. Oh, very similar. So let me go ahead and let you do this one. I'm going to find the intercepts. So just like I did on this example, to find an x-intercept, you want y to be 0 and vice versa. To find a y-intercept, you want x to be 0. You need to find y, therefore x is the one that's 0, so you can find the y value. Alright, let me look at the next one. Intercepts again. Perfect, perfect. So let's go on to the next type. Okay, here's one. Graph both linear equations in the same grid. Decide the lines are parallel, perpendicular, or neither. Okay, so let me clear all of this and go back to those two equations real quick. The two equations are 3x plus 3y equals negative 3. And negative 3x plus 3y equals, I don't remember, 12. And I want to graph these two lines. It didn't say to graph them by intercepts, so I can choose any method I want here. Okay. Intercepts may still be the easiest method when it's set up in this form already for graphing something. For example, in that first line, 3x plus 3y equals negative 3. If I want to graph this, to find the y-intercept, I can plug 0 in for x, divide by 3. I get y equals negative 1. And for the other intercept, I can plug 0 in for y, get 3x equals negative 3, so x equals, again, divide by 3, negative 1. So these are the intercepts, 0, negative 1, and negative 1, 0. Okay, I just scribbled out because when I plugged in 0, 3 times 0 is 0 right there, and 3 times 0 is 0 right here. Okay, for the other line was negative 3x plus 3y equals 12. Okay, so let's find the intercepts here. So I find the y-intercept, I plug in 0 for x. Divide by 3. Y equals 12 divided by 3 is 4. And it was the equation 3x plus 3y equals 12. So to find the x-intercept, plug in 0 for y. Divide both sides by negative 3. So x is equal to negative 4. So this would be the intercept where x was 0, y is 4. That's the y-intercept. And the x-intercept is x is negative 4 when y is 0. So a little bit more practice there in solving by intercepts. And let's graph those. Okay. So the first one was at negative 1, negative 1. I'm going to go ahead and make that bigger. Okay, so the first one was at negative 1 and negative 1. The two intercepts were the same thing, 0, negative 1, and 1, negative 0. Oh, I'm sorry, 0, negative 1, and negative 1, 0. And the other one was 0, 4, and negative 4, 0. Okay, so 0, 4, and negative 4, 0. Okay. Oops. I did this line wrong. I was thinking those were both negative ones. I put a positive one for some odd reason. It should have been at negative 1. That one was supposed to be negative 1, 0, and 0, negative 1. So if you're wondering what the heck I didn't know what I did. I put it in the wrong spot. So if you do put a dot in the wrong spot, you can click on it and drag it to the right one. Okay, so I have done so. This is what they should look like. So that would be my graph. Now I want to know if the lines are parallel or perpendicular or neither. Okay. Now to do that, I can tell they're not parallel. They might be perpendicular, but I don't really know, and I'm not going to know until I solve for the slope on each of them. Okay, so let's do that. The two lines were 3x plus 3y equals negative 3. So to find the slope, I need to solve for y. So subtract 3x from both sides. 3y equals negative 3x minus 3. Divide by 3, divide by 3. Y equals negative 3 divided by 3 is negative 1, minus negative 3 divided by 3 is negative 1. It's negative 1x minus 1. Forgot my x for a second there. The other equation was negative 3x plus 3y equals 12. So in this case, I'm going to add 3x to both sides. We'll get 3y equals 3x plus 12. Divide both sides by 3. And y is equal to 3 divided by 3 is 1x plus 12 divided by 3 is 4. Okay, so these are my two equations, my two lines. Now, I could have just done this first and not done intercepts, and I could have graphed them this way. And let me go back and look at the graphs just to compare. I'll consider this one right here. The intercept is 4, the slope is 1, so I could have chosen to graph this one by starting at 4 and going up 1 over 1 and clicking right here. Okay, so that would have also worked. Okay, so this one didn't tell me specifically to do intercepts, so I could have just used the slope and the intercept instead of having to use both intercepts. Okay, it's another technique for graphing. Same thing on the other one. The y-intercept was negative 1, the slope was negative 1, so I could have went down 1 over 1 and graphed it with those 2 points. It is the same two lines. Okay. What I can see now is that the slope of the first one is negative 1, and the slope of the second one is 1. To be perpendicular, these slopes have to be opposite signs, which they are, and reciprocals of each other, which they are, because the reciprocal of 1 is 1. 1 over 1 is still 1. So these are perpendicular. I ran out of room to write perpendicular, but you get the idea. Okay, so for example, again, just for perpendicular, if one of the slopes is 3, the other slope would have to be negative 1/3 to be perpendicular. Because it's 1, it's negative 1 over 1, which is negative 1. So, 1 over 1 is just 1, so there we go. Okay, so those are perpendicular also. Alright. 52 I might have missed. Yep, I skipped the bottom of 52. So the graph on this one. Okay, that graph looks a bit different from yours. Okay. So you can graph that one either by intercepts or by slope-intercept form. Let me go ahead and look at 60 to see what that one looks like. Okay. Write the equation. Okay, I'm going to go into this one because I've only got a couple more minutes left before the video times out. And if we have more questions about graphing, I will totally do some more on that. Okay, let me look at that one again. The question is going to be, write the equation satisfying the conditions. So the conditions are, it has a slope of -1/5 and it passes through that ordered pair. So let me go ahead and move that away. The slope is -1/5. It passes through the ordered pair 5, -9. Alright, so we're using point slope form, which is y minus y1 equals m times x minus x1. So we start by saying y minus -9 equals m, which is -1/5, times x minus 5. And then you simplified, just to get rid of that double negative right there. Oops, I forgot my parenthesis. Okay, so this was your first answer. This is in simplified point slope form. What we need to do now is simplify it into slope-intercept form by completing the distributing going on. Okay, so I've got y plus 9 equals -1/5 times x is -1/5 x. The two negatives, when I multiply this together, are going to make a positive, and 5 goes into 5 once, so that'll be a 1. Right, 1 times 1 will be 1. Or think about it as 5 times 1 is 5, divided by 5 is 1. Okay. Subtract the 9 from both sides. Y equals -1/5 x minus 8. So that would be the correct answer on this one. Okay. So there were two answers. One is the show your work step, the unsimplified version that I get pretty much directly from using this formula here. I did simplify a tiny bit just to get rid of double negatives, but I didn't distribute. Okay, that would be the answer for showing my work. And then my final answer really is once I get it simplified and solved for y. Alright, so take a look at these. I know I talked kind of fast because these videos have a time limit on them, so if you want me to go over them again, and looked at a couple of the graphing, if you want to see some more of those, let me know, and I can do them.